right, we're working on scientific notation today in Algebra 1. This is lesson 710. I'm going to teach you some really cool things. Our essential question is, can you use scientific notation? So notice the number is given, but the scientific notation always has a number with a decimal in the rest of the number, times 10 to a number. So remember, since this one went 1, 2, 5, 8, 11, I know that I have to move that decimal 11 places to the right. Right, so here again I have 4.709, but this one I have to move 9 places. So that's why the scientific notation is 4.709 times 10 to the 9th. When you're moving backwards, I think there's a little boo-boo here. Do you see my boo-boo? Yeah, this should be a -4. So when you're moving backwards, here is where I want the decimal, but I have to move it 1, 2, 3, 4. So again, we're going from decimal notation to scientific notation. And the next one is done right. 2.5 times 10 to the -13th. If I had to write it out, it would be like this, except that decimal looks like a comma. We don't want it to look like a comma. So let's write this number in scientific notation. We want the decimal to be right here. Well, I know these are 3, 6, 9, 12, 13. So I'm going to write this as 6.483 times 10 to the 13th power, because I'm going to move that decimal 13 places to the right from decimal notation to scientific notation. All right, let's see how many spaces I have this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know I want this to be 8.9, and because we want the decimal place to go to the left, I'm going to put that to a -10. All right, so that is going from decimal or numeric form to scientific notation. Now we're going to go from scientific notation to decimal form. So for this one, I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, you have to kind of think about how many numbers you want. So I put in all my little commas. Don't forget your commas. And that is 6,470,000,000. All right, the next one does have a -7, so we have to go -7 places. So we were here, and I want to go 1, 2, 3, 4, 5, 6, 7. I want to put the decimal here, and I'm going to fill in the zeros in green so you can see that I'm filling them in each space. And I'm just going to rewrite over my number. All right, how do you think you're doing? Have you seen scientific notation form before? Now, what if I have to divide? Okay, I know what I know. With 10 to the 12th divided by 10 to the 4th, wouldn't that just be 10 to the 8th? So really, I have to take 3 and divide it into 9.3, because 3.0 is just 3. Well, 3 goes into 9 3 times. 3 goes into 3 1 time. So this answer will be 3.1 times 10 to the 8th power. What happens if I have to multiply them? If I have to multiply them, I am going to old school multiply. 6.2 times 3.5. And I get 10, 31, make a mark, 6 and 9. So it looks like I get 1270, but since I have 2 decimal spaces, I know it's going to be 12.7. And when I multiply my bases, 10 to the 5th times 10 to the 8th, remember, I add the exponents. Now, here's where things get a little bit more difficult. Notice I have 12.7, but don't I want 1.27? All right, so here's what I tell my students. When you go from 12 to 1, you're making the number smaller. When I make this number smaller, I have to make the exponent bigger. If I make the number bigger, I have to make the exponent smaller. All right, the last thing we're going to do is more King Henry died Monday drinking chocolate milk. So I'm going to write that out for you. Remember, this could be meters or liters or grams or anything of the such. And died Monday drinking chocolate milk. So I'm going from the liter, or the main unit, to milliliters. 1, 2, 3. So I have to move this decimal 3 places. All right, now I'm going from grams. Meters can be grams or liters. And I'm going to kilograms. So now I'm moving 1, 2, 3 to the left. So here's my decimal, 1, 2, 3 to the left. So 1 gram is equal to 0.001 kilogram.